Hello viewers, welcome to my YouTube Engineer Maths channel. In today's class, we are going to study the applications of matrices. Under this, we are going to study the solution of system of linear equations in two variables and in three variables by using the method of inversion. If it is a system of linear equations in two variables, then the equations are of the type a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. This equation consisting of the two variables, one is x and another is what, y. And if the equations are in terms of the three variables, then the equations will be of this form. So a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. The general form of the system of linear equations in two variables or in three variables is that in the left hand side the variables x and y should be present, and in the right hand side the constant should be present. If it is in terms of three variables, the general form of the system of linear equation is the left hand side consisting of the unknown variables, the three variables x, y, z. Variables should be present in the left hand side and the constant should be present in the right hand side. So this is the general form of the system of linear equations in three variables. Then to find the solution of the system of linear equations, first we have to express the given equation in terms of the matrix equation. Writing the given equations in the form of matrix equation as Ax is equal to B. So here Ax is equal to B. This equation is known as what? The matrix equation. Where what is A here? A is a square matrix whose elements are nothing but what? The coefficients of x and y of the given equations. So the first row of the matrix A is nothing but the coefficient of x and y of the first equation, that is a1, b1. Second row of this matrix A, that is a2, b2, which are nothing but the coefficients of x and y of the second equation. So if what is x here? So x is the column matrix consisting of the unknown terms x and y. And what is B? B is also a column matrix, B whose elements are nothing but what? The constant terms which are present in the right hand side of the given equation. After writing the given equations in the form of matrix equation Ax is equal to B, we have to find A inverse by using the adjoint method. Once after getting the A inverse by using the adjoint method, the next step is what? To find the solution of the system of linear equation. Finding the solution of the system of linear equation means what? We are going to find the values of x and y from the given equation. So after finding A inverse, pre-multiplying matrix equation Ax is equal to B by A inverse, we get. Now let us multiply A inverse to the given equation. So pre-multiplying means before. So A inverse into X is equal to A inverse into B. So this can be further written as A inverse into A into X as it is equal to A inverse B as it is. But in the definition of the inverse of a matrix, we have seen that A inverse into A is equal to what? I. So therefore, this A into A inverse is replaced by what? I. So into X as it is equal to A inverse into B. If you multiply identity matrix to any matrix, you will get that matrix only. So X equal to A inverse into B. Where what is A inverse? A inverse is what? Adjoint of A divided by a determinant of A. So this is the method behind to find the solution of system of linear equations in two variables and in 3 variables by the method of a inversion. Now let us consider one example. Solve the equations 2x plus 5y minus 1 equal to 0 and 3x plus 2y minus 7 equal to 0 by the method of inversion. Solution. So the given equations 2x plus 5y minus 1 equal to 0 and 3x plus 2y minus 7 equal to 0, these two equations are not in a standard form. Why the two given equations are not in a standard form? Because in a given equation, the constant is present in the left hand side. So first we have to transfer that constant into what? The right hand side. So then the given equations can be written as, so this 2x plus 5y equal to this minus 1 becomes what? Plus 1. And the second equation 3x plus 2y equal to, transfer this minus 7 in the right hand side becomes a plus 7. Now the constants are present in the right hand side. So we have written the given equations into the standard form. So the above equations can be written in the form of matrix equation as Ax is equal to B. Say equation number 1. So here Ax is equal to B is known as the matrix equation, where A is a matrix consisting of the coefficients of x and y from the given equations. So 2, 5 is the first row and 3, 2 is the second row. So x is the column matrix consisting of what? The unknown terms x and y. Whereas B is again a column matrix whose elements are nothing but the constant present in the right hand side of the given equation. Once after writing the given equations in terms of the matrix equation X is equal to B, the very next step is what? To find A inverse by using the adjoint method. Consider the matrix A is equal to 2, 5, 3, 2. Then the determinant of the given matrix is what? Determinant of 2, 5, 3, 2. So let us find the value of this determinant. 2, 2 are 4, minus 3, 5 are 15. So 4 minus 15 is what? Minus 11. So which is a non-singular matrix. Therefore, A inverse exists. Now to find the A inverse by using the adjoint method, one should know what are the minus and cofactors of the elements of the determinant of a given matrix. So the M11 is here 2, M2 is what here 3, M21 is 5 and M22 is what here 2. So after writing the minus, the next step is what? To find the cofactors. The cofactors are denoted by the capital letters A. So A11 equal to 1 plus 1 is what? 2. Even number. So you will get a positive sign into the minor is what here 2. Then let us find the cofactor of this M12 as what? A12. So if you add these two numbers 1 plus 2, we are getting 3, the odd number. If the addition is odd number, then you have to write the negative sign into the minor. Minor is what here? 3. Then find the cofactors A21. Again 2 plus 1 is 3, which is an odd number, so you will get negative sign into the minor. So minor is what here? 5. And the cofactor A22. So if you add this 2 plus 2, you will get 4, which is an even number. You will get positive sign into the minor. Minor is what here? 2. Now let us find the adjoint of A is the transpose of a matrix consisting of what? The cofactors. So A11, A12, A21, A22. That is A11 is 2, A12 is minus 3, A21 is minus 5, A22 is 2. The transpose. Let us take the transpose of this matrix means what? Rows are to be converted in terms of columns. So the first row 2 minus 3 becomes first column and second row minus 5 2 becomes the second column minus 5 2. Now we find the A inverse by using this formula adjoint of A divided by determinant of A. What is the determinant of A? So minus 11. So minus 1 upon 11 into adjoint of A. So adjoint of A is what? 2 minus 5 minus 3 2. So this is equation number 2. Once after finding the A inverse, the very next step is what? To follow the procedure to find the solution of the system of linear equations. So for that, pre-multiplying equation 1 by A inverse, So this is the equation number 1. You have to multiply pre-inverse. You have to pre-multiply A inverse to both sides of this equation 1. So then what will get? A inverse into Ax is equal to what? A inverse into B. This can be further written as A inverse into A into X is equal to the right hand side A inverse into B as it is. But in the definition of the inverse of a matrix, we have seen that A into A inverse is what? I. So replace this A into A inverse by what? I into X as it is, the right hand side A inverse into B. So I into X is what? X equal to A inverse into B. So X is equal to A inverse. From equation number 2, what is A inverse? Minus 1 upon 11 into 2 minus 5 minus 3, 2. This is the A inverse into B. What is B? B is what? 1 7. So 1 7. So from equation number 2, we replace this A inverse by what? Minus 1 upon 11, 2 minus 5 minus 3t. So from equation number 2, we replace this A inverse by this term into the matrix B as what? 1 7. Now let us take the multiplication of these two matrices by keeping this minus 1 upon 11 as it is. So X is equal to minus 1 upon 11. So the rows are to be multiplied with column. So 2 into 1 plus minus 5 into 7. Then minus 3 into 1. Minus 3 into 1 plus this 2 into 7. 2 into 7. 2 ones are 2. Plus minus become minus. 5 7s are 35. So minus 3 into 1 is minus 3. So plus 2 7s are 14. So minus 1 upon 11 into 2 minus 35 is minus 33. Minus 3 plus 14 is what? 11. Now let us multiply minus 1 upon 11 to this minus 33. So means what? Minus minus become plus. 33 upon 11, 11 3s are. And minus plus become minus. 11 1s are 11. So now in the left hand side one matrix is there. And in the right hand side one matrix is there. In between left hand side and right hand side equal to sign is there. That means what? These two matrices are what? Equal. So by equality of matrices we get. So this X equal to 3 and Y is equal to what? Minus 1. So this is the solution of the given system of linear equation in terms of the two variables. Now whatever values we got, X is equal to 3 and Y equal to minus 1. Whether those values are correct or wrong. To know this, we can do the verification. See, the verification is not compulsory. Just for the sake of our knowledge purpose, I am explaining you the verification. Even in exam also, you don't go for this verification. Okay, if the time is there with you in the exam, then you may proceed to what? The verification. Okay, verification means what? You have to put the value of X equal to 3, Y equal to minus 1 in any one of the two given equations, and after substituting you see that whether LH is equal to RHS or not. So let us consider the first equation. So 2x plus 5y equal to 1. So 2 into x, x is 3 plus 5 into y, y is minus 1 equal to right hand side 1. So 2 3s are 6. So plus minus become minus. 5 1s are 5 equal to 1. So 6 minus 5 is what? 1 equal to 1 means what? The left hand side is equal to the right hand side. So hence we can say that whatever the value of x and y we got here as x is equal to 3 and y equal to minus 1, they are what? 100% correct. Take the next example. Solve the following equations by the method of inversion. X minus y plus z equal to 4. 2x plus y minus 3z equal to 0. X plus y plus z is equal to 2. So by using the method of inversion, we have to solve these three equations. Means what? We have to find the values of what? X, y and z. Solution. Given equations are x minus y plus z equal to 4, 2x plus y minus 3z equal to 0, x plus y plus z is equal to 2. If you see, the right hand sides of these equations are what are the constant terms. The constant terms are present in the right hand side. Means what? The given equations are in a standard form. The above equations can be written in the form of matrix equation as Ax is equal to B. So you know that this one Ax is equal to B is known as what? A matrix equation. Say equation number 1. Where what is A? A is a matrix whose elements are nothing but the coefficients of x, y and z in the given equations. So here coefficient of x is 1, y is minus 1, z is 1. Therefore, the elements of the first row of this matrix is what? 1, minus 1. Similarly, the elements of second row are what? 2, 1 and minus 3. And the elements of the third row are what? 1, 1, 1. X is the column matrix consisting of the terms x, y and z. And B is the column matrix consisting of the constant terms of 4, 0, 2. Now let us find the determinant of the given matrix. So determinant of A equal to 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1. Now let us find the value of this determinant. So 1 into 1, 1s are 1, minus 1 into minus 3 is minus 3. So minus of this term is minus 1 into 2 into 1 is 2, minus 1 into minus 3 is what? Minus 3. Plus 1 into 2 into 1 is 2, minus 1 into 1 is what? 1. So determinant of A equal to 1 into bracket 1 minus of minus is plus 3, plus minus becomes plus 1 into 2 minus of minus 3 is 2 plus 3, plus 1 into 2 minus 1 is 1. Or determinant of A equal to 3 plus 1 is 4, plus 1 as it is, 3 plus 2 is 5, plus 1 as it is. Or determinant of A equal to what? 1 4s are 4, plus 5 1s are 5, and this plus 1 will remain as it is. So determinant of A equal to 4 plus 1 is 5, 5 plus 5 is what? 10. So not equal to 0, therefore A inverse exists. Once after confirming that the given matrix is a non-singular matrix, means the inverse of the matrix exists. Next, what you have to do? You find the minus of each element of this determinant of A. Okay, M1 will equal to what? 1 1s are 1, minus of minus 3. So 1 plus 3 is what? 4. M12 is what? 2 minus of minus 3 is 2 plus 3 is 5. M13 is what? 2 minus 1 is 1. M21 is minus of minus 1 is minus 2. M22 is what? 1 minus 1 is 0. M23 is what? 1 minus of minus 1. So 1 plus 1 is that is 2. So M3 is what? 3 minus 1. So 3 minus 1 is 2. M32 is what? Minus 3 minus 2 square. Sorry. M32 equal to what? Minus 3 minus 2. So minus becomes plus 5. And finally, M33 is what? 1 minus of minus 2. That is 1 plus 2 equal to what? 3. So these are what? These are the minors of the elements of the given matrix. Now what is the next job? To write their cofactors. So A11, so 1 plus 1 is what? 2. Even number will get positive sign here. So into minus, so minus is what? 4. M12, 1 plus 2 is what? 1 plus 2 is 3, odd number. That's why you will get a negative number. And the value of A12 is what? 5. So A12 is what? Minus 5. Similarly, A31, A21 is 2, A22 is 0, A23 is minus 2, A31 is 2, A32 is what? 5. So M33 is 1 minus of minus 2 is that is 1 plus 2 equal to 3. And A33 is what? Plus 3 equal to what? 3. Therefore, adjoint of A equal to transpose of the cofactors of the elements of a determinant of a given matrix. Therefore, adjoint of A equal to transpose of A11 is 4 minus 5 1, A21 is 2, A22 is 0, A23 is minus 2, A31 2, A32 is 5, A33 is what? 3. Then the transpose means what? The rows are converted in terms of columns. So 4 minus 5 1, first row becomes first column, 4 minus 5 1. Second row 2 0 minus 2 becomes 2 0 minus 2, and third row 2 5 3 becomes the third column 2 5 3. Therefore, A inverse is given what? 1 upon determinant of A into adjoint of A. So the value of determinant of A, the value of determinant of A is what? 10. So 1 upon 10 into the adjoint of A, 4 2 2 minus 5 0 5, 1 minus 2 3. So equation number 2. Here we have obtained the value of what? A inverse. Next is what? To find the values of unknown terms. For that, pre-multiplying A inverse on both sides of equation 1. So pre-multiply A inverse on both sides of what? Equation 1. So we get So A inverse into AX is equal to what? A inverse into B. So A inverse into A into X is equal to A inverse into B. But A inverse into A is what? A inverse into A is the identity matrix I into X is equal to A inverse into B. I into X is nothing but X is equal to A inverse into B. So X is equal to what? A inverse is 1 upon 10 into A inverse. So from 2 we replace A inverse as what? This 1 upon 10 into the matrix. So into B, B is what? B is the column matrix consisting of what? The constant terms of the given equation, that is 4, 0 and 2. Take the multiplication of this matrix and this matrix. So 1 upon 10 as it is, rows are multiplied to columns. So 4 into 4 plus 2 into 0 plus 2 into 2. Second row minus 5 into 4 plus 0 into 0 plus 5 into 2. Then third row 1 into 4 plus minus 2 into 0 plus 3 into 2. That is 16 plus 0 plus 4. Minus 4 into 4 is 20 plus 0 plus 5 2 is 10. So 4 plus minus 2 into 0 is 0 plus 3 2 is 6. So 16 plus 4 is 20. Minus 20 plus 10 is minus 10. 4 plus 6 is what? 10. Of course 1 upon 10. Now let us multiply 1 upon 10 to this 20. 1 upon 10 into 20. So the division takes place. 10 2s are. Here 10 1s are. 10 1s are. That means 2 minus 1. So now in the left hand side and in the right hand side, two matrices are there. In between equal to sign is there. That means what? These two matrices are equal. So hence by equality of matrices we get x equal to 2, y equal to minus 1 and z is equal to 1. Now whatever the values of x, y and z we got, whether those values are correct or wrong, this can be judged by doing the verification. So verification, take any one of the given equations. I have taken here the first equation. So replace the values of x, y and z in place of x, y, z. So x is 2 minus y is minus 1 plus z is a 1 equal to the right hand side is what? 4 as it is. So 2 minus or minus 1 is plus 1 equal to 4. So 2 plus 1 is what? 4 is equal to 4. Therefore you can say LHS is equal to RHS. What it means? It means that whatever the values of x equal to 2, y equal to minus 1, z equal to 1 we got here, they are what? They are the solution of the given equations. Now take the next example as a word-based problem. The example is like this. The cost of 4 pencils, 3 pens and 2 erasers is rupees 60. The cost of 2 pencils, 4 pens and 6 erasers is rupees 90. Whereas the cost of 6 pencils, 2 pens and 3 erasers is rupees 70. So find the cost of each item using the matrices. So the word-based problem, first you have to represent in the form of what? The linear equations. For that, so we don't know what is the cost of the pencil, what is the cost of a pen and what is the cost of eraser. Now in the beginning I am going to assume that, say the cost of a pencil means single pencil, one pencil. The cost of a pencil is rupees X, the cost of a pen is rupees Y and the cost of an eraser is rupees Z. Then using the given information we get the equations as, so 4x plus 3y plus 2z equal to 60, 2x plus 4y plus 6z equal to 90 and 6x plus 2y plus 3z is equal to 70. Once after representing the word-based problem in terms of the equations, the further part will be what is similar as we have seen in the previous example. So the above equations can be written in the form of matrix equation as a Ax is equal to B. The equation Ax is equal to B is known as the matrix equation. See equation number 1. Here A. What is A? A is a square matrix whose elements are what? Whose elements are nothing but the coefficient of x, y, z. The first row of this matrix is nothing but coefficient of x, y, z of the first equation. The second row 2, 4, 6 of this matrix A is nothing but what? The coefficient of x, y, z of the second equation. The elements of the third row. that is 6 to 3 are nothing but what? The coefficients of x, y and z of the third equation. So where this is the matrix A, and matrix X consisting of what? The unknown terms x, y and z, and the matrix B is consisting of the constant terms which are present in the right hand side. So 60, 90, 70. Now let us find out the value of this determinant A. Determinant of 4, 3, 2, 2, 4, 6, 6, 2, 3. Find the value of this determinant. So 4 into 4, 3 is 12, minus 2, 6 is 12. So minus 3 into 2, 3 is 6, so minus 6, 6 is 36. So plus 2 into, so 2 2s are 4, minus 6 4 are 24. So determinant of A equal to 4 into 12 minus 20 is 0, minus 3 into 6 minus 36 is minus 30, plus 2 into 4 minus 24 is what? Minus 20. So 4 into 0 is 0. So minus becomes plus. 3 3 is 9, 90, plus minus minus 22s are 40. So 90 minus 40 is what? 50, which is not equal to 0. Therefore A inverse exists. Next we have to find A inverse by using the adjoint method. To find A inverse, let us write down the minor of each element of the determinant of a given matrix. So M11 is 0, M12 is minus 30, M13 is minus 20, M21 5, M22 0, M23 is minus 10, M31 is 10, M32 is 20, M33 is 10. Once after getting the minus, we can write down the cofactors. Say A11 is what? 1 plus 1 is 2. Even number will get positive sign. Into the minor, minus 0. So everything, the value of A11 is what? 0. Next what? A12. 1 plus 2 is 3. Odd number will get minus sign. Into the minor, minus what? Minus 30. So minus of minus is what? Plus. So plus 30 is the value of A12. Next A13. 1 plus 3 is 4. Even number, you will get positive sign. Into minor. Minor is what? Minus 20. Plus minus is minus 20 as it is. Then A21. 2 plus 1 is what? 2 plus 1 is 3. Odd number will get negative sign. Into the minor, minor is what? 5. So minus plus becomes a minus 5. Then A22, 2 plus 2 is what? 4. Even number will get positive sign. Into the minus 0. So it will be 0. Then A23, 2 plus 3 is 5. 5 is an odd number will get negative sign. Into the minor, minor is what? Minus 10. Minus minus plus 10. Then A31. A31 is what? 3 plus 1 is 4. Even number will get positive answer. Into the minor, minor is 10. So you will get finally 10. Then A32, 3 plus 2 is what? 5. Odd number will get minus sign. Into the minor is 20. So minus 20. A33, 3 plus 3 is 6. So which is the positive number? You will get plus 1 into the minor, minus what? 10. So plus 10. Now after finding the cofactors, we calculate the adjoint of A. Adjoint of A is what? The transpose of a matrix consisting of the cofactors. That is adjoint of A. So 0, 30, minus 20, minus 5, 0, 10, and 10, minus 20, 10. 10, minus 20, 10. Take the transpose. Rows are converted into sub columns. 0, 30, minus 20, 0, 30, minus 20. Minus 5, 0, 10, minus 5, 0, 10. 10, minus 20, 10, 10, minus 20, 20. So now A inverse equal to what? 1 upon determinant of A into adjoint of A. So determinant of A is how much? 50. 1 upon 50 into the adjoint of A as it is. Pre-multiplying equation 1 by A inverse. So A inverse into AX is equal to A inverse into B. So A inverse into A into X is equal to A inverse into B. So A inverse into A is what? I into X is equal to A inverse into B. So identity matrix into X is X. X is equal to A inverse into B. Now from equation number 2, we replace the value of A inverse as what? 1 upon 50 into 0 minus 5, 10, 30, 0 minus 20, minus 20, 10, 10 into the matrix B. B is the column matrix consisting of the constant terms which are present in the right hand side of a given equation 60, 90, 70. Now take the matrix multiplication of these two matrices. So 1 upon 50 into, so 0 minus 4, 5, 0 plus 700, 1800 plus 0 minus 1400, minus 1200 plus 900 plus 700. So minus 450 plus 700 is 250. 1800 minus 400 is what? 400. And minus 1200 plus 900 plus 700 is what? 400. Now take the division up to 50 upon 50 is 5. So 40 upon 50 is 8. Again, so 400 upon 50 is 8. Again, 400 upon 50 is what? 8. So 250 by 50 is 5. 400 divided by 50 is 8. 400 divided by 50 is what? 8. So in the left hand side one matrix is there, in the right hand side another matrix is there, in between these two matrices equal to sign is there. So by equality of two matrices we get x is equal to 5, so y is equal to 8, z is equal to 8. Therefore the cost of a pencil is rupees x. Or what is x? X is 5. So rupees 5 is the cost of one pencil. The cost of a pen is rupees y. What is y? Y is equal to 8. So rupees 8 is the cost of one pen. So the cost of an eraser is rupees z. So what is z here? 8. So therefore rupees 8 is the cost of one eraser. Now we can do the verification. Take any one of the equation. So 4x plus 3y plus 2z equal to 60. So x is 5, y is 8, z is 8 equal to 60. 4 5 is 20, 3 8 is 24, 2 8 is 16. 16 plus 24 is 40 plus 20, 60 equal to 60. So LH is equal to RHS. That means whatever the values of x, y and z we got, they are what? 100% correct. If you feel that this video is really helpful for you, then you please like it, share it, write your valuable comments on this video, and do not forget to subscribe the channel.